shift functions. So we're going to be talking about normal functions, or regular functions, what you want to call them, any function I should say. And we're going to see what we do to shift them left, right, up, down, and eventually make them skinnier and fatter, and reflection as well. So right now they're asking us to change, we have an interactive graph, and we want to change it from our regular y equals f of x, and they have a new graph here. So we're going to go to the camera and look at a couple of rules. So first thing we have is vertical shifts. Vertical shifts is the graph moving up and down. So our black graph is our standard regular function, which is x squared, or something similar to that. And if we have f of x plus a number, which this time we have plus 3, you can see right here, it's going to move up 3 units up. Okay? And if we have subtract some number, and this one we have minus 3, it's going to move down 3 units. And we can have a horizontal shift. You can see here we have left and right. If we have x plus c, which is x plus 3, and that's all squared together, so it's inside parentheses next to the x, that's going to shift to the left. Okay, that's a little bit different. You would think the plus would go right, but it actually goes opposite direction, goes to the left. And then the negative one is what goes to the right. So let's look at our first question again. So we have x squared, and then so inside our parentheses we have x minus 2. So going back to our rules down here, minus some number, it's 2, it's going to shift it right 2 units. So our bottom, our vertex, will shift to the right 2 units. And then we have a negative 4 back here. So let's look at what the negative 4 does. Okay, so that's a vertical shift. Minus some number, it's c, so minus down 4 units. So we need to bring that vertex down 4 units. And actually, so we know we got to go right 2 and down 4 because they started this off not on the exact same plane. Let's see here. There we go. Okay. We're going to match the graph up first, and then we're going to move our graph. So we went over 2. So make sure you move them both over 2. And then we're going to go down 4. So we start at 9, and we're going to go down to 5. Because 9 minus 4 is 5. And that should be our graph. Let's check it. There we go. Very slow. And we're good. Okay, next question. Okay, question 2. Graph of y equals x squared is shown on the grid below. Okay, pretty sure we had before. Which of the following is the graph of y equals x plus 5 squared minus 3? Choose one answer. All right, so we have plus 5, which means, where are we at here? Here's my camera. All right, so remember, when it's inside, plus 5 means we're going to the left 5 units. Okay, this is going to the right, so it's not A. Also right, not B. So it's either C or D. Next question is minus 3. Okay, this means that we're going to be going down 3. It's a vertical shift. We go down 3 units. And so looks like C goes down 7 units, and D goes down to 3, because this matches up with 3 right here. So it is D. Okay, next question. So we have 2 graphs. The graph of y equals g of x is a transformation of h of x. So h of x is the original, and g of x is the transformation of that. Okay, so this is what we're going to try and write a formula for the function of g in terms of h. So we need to write our function first. So g of x. Now, we're going to look at how far left or right it went. So here's our original, the blue one. It goes from -2, is the vertex, over to +5. So that's a shift to the right of 7 units. Okay? Well, shift right 7 units means that we have to have a negative c, or -7. So -7 is on the inside. On the outside, you see how far up or down we go. We're at -7 originally, and we go up to -2. So we're going up 5. Up 5 means that we have on the outside. Up 5, positive c, or positive 5. Please check include the wrong variable. Let's see here. What am I doing wrong? Oh, this seems to be h of x, not g of x. In terms of, this is h of x. We're trying to create g of x. And there it is. Okay, next question, last question. So g of x is a transformation of y of x. Sorry, y equals h of x. So this is h of x. That's the original. G of x is the new one. Given that h of x is x minus 4 plus 2, write an expression. Okay, so I'm going to write the exact same thing first. All right, now we're trying to create g of x. So g of x is a function of this. So let's see how far left, right we go first. So from 4, we go all the way to, looks like -6. So from 4 to -6, you do -6 minus 4, which you get -10. So we're shifting left 10 units. Left 10 units means we have a plus 10 in here. So we're going to add 10 to the inside. So we have -4 already. So we're going to add 10 to that. It means that we get plus 6. And then we're going from here down. So 1, 2, 3, 4, 5, 6, 7, 8. So we're going down 8. So we're going to subtract 8 from this number, which means we're going to -6. You could have also just looked at the vertex, and you can see that we have -6 over, so we would add plus 6, and then -6 here, we would add -6 too, following the original rules. But that's, you can do it both ways, I guess. And checking our answer. And we are done.